In this lesson, we're going to learn how to estimate square roots of non-perfect squares and compare them. So let's take a look first at what a perfect square number is. A perfect square number is a number in which an integer has been multiplied by itself, raised to an exponent of 2. So 1 squared we know is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. So all of these numbers are considered perfect squares because I simply multiplied a number by itself to get that product. Now we are going to learn how to take the square root of numbers. Taking the square root uses the radical symbol. So let's take a look at the parts of a radical symbol. The outside number is called the index. Then we have the radical symbol. And then under the radical is called the radicand. Now we're going to just focus on taking the square roots, which means that the expression was created by squaring a number. Many times, though, we don't use the index 2, we don't write it, but it's implied. So if we want to undo this squaring on the 1, we take the square root of 1, which gives me back 1. If I take the square root of 4, that gives me the root 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5, and so forth. So you can see taking the square root of perfect numbers is very easy. Before we move on to learn how to estimate numbers that are not perfect squared, let's finish out our perfect square list. So again, 1, 4, 9, 16, 25, 36, 49, 64 are perfect squares. Let's continue with our list. We have 81, 100, 121, 144, 169, 196, 225, 256, 289, and 324. If you want to do 19 squared, that's 361, and 20 squared is 400. So ideally, you're going to want to memorize all these perfect squares. It will make the lesson much easier. Like I was saying, most numbers are not perfect square. For example, the square root of 2. There is no number that we multiplied by itself to give me 2. So 2 is not a perfect square number. The same with the square root of 3. 3 is not a perfect square. If I take the square root of 3, I'm not going to get an integer. This is where we're going to learn how to estimate. You can see that perfect square numbers are easy to plot on a number line. If I wanted to say plot the square root of 25, that really is just the value 5. So let's take a look at our first example that is not a perfect square number. The square root of 20. If I asked you to give me an approximation of the square root of 20, the first thing you're going to do is decide, okay, what two perfect square numbers does the square root of 20 come between? So again, I have these numbers in my mind, they are memorized, and I'm like, oh, the square root of 20 comes between the square root of 16 and the square root of 25. So somewhere in between here lies the square root of 20. But again, we're trying to estimate it. We're trying to maybe plot this on a number line. What is the square root of 16? Well, we know that it is 4. We know the square root of 25 is 5. So the square root of 20 is somewhere between 4 and 5. So we know our estimation is going to begin with 4 point something. So we're going to come back and now I'm going to teach you how to find the decimal part. Before we find the decimal part, we're going to write it as a fraction. So step 2, to find the decimal part, again, we're going to find the fraction first. I always like to find the denominator part first. So we're going to have 4 is our whole number. And our denominator for the fraction part is the difference between the perfect square numbers. So from 16 to 25 is a difference of 9. To find your numerator, you simply find the difference between the first perfect square and the number you're estimating. So from 16 to 20 gives us a value of 4. So the square root of 20 is about 4 and 4/9. but you're going to be asked to estimate this to the 10th. So we need to convert 4/9 to a decimal. So we're going to have to do a little log division. 4/9 is the same as saying 4 divided by 9. So we're going to divide 9 into 4. 9 goes into 4 0 times, forcing us to write a decimal. 9 into 40 goes 4 times. 4 times 9 is 36. Bring down your 0, and I can see that I'm going to keep getting a 4. So 4/9 is about 0.4, and if you want to put repeating, that is fine. So if I wanted to plot this on the number line, 4.4 is somewhere about here. Again, these are approximations. So when we're taking a look at the square root of 12, we're going to have our perfect square numbers memorized, and it doesn't hurt to write them down. So step 1, 12. 12 comes between 9 and 16. So we're going to have the square root of 9, we have the number we're estimating, and then we have the square root of 16. So the square root of 12 comes between the square root of 9 and 16. Now, what is the square root of 9? Well, that's 3. And the square root of 16 is 4. So somewhere 3 point something is going to be the square root of 12. So we know this whole number part is 3. Now, we're going to find the fraction part. So again, I'm going to simply find the difference between the two perfect squares. So from 9 to 16 is 7. And then my numerator is the first perfect to the number we're estimating. That's a difference of 3. So 3 3/7 is about the square root of 12, but we want a decimal. So we're going to divide 7 into our numerator. It's going to force us into a decimal. 7 into 30 goes 4. We're going to subtract, bring down a 0. 7 into 20, almost 3 times, but not quite. So we get a 2 telling us that we're going to keep this to 0.4. So 3.4 is about the square root of 12. So I could graph that on a number line. The square root of 30. The square root of 30, so we're looking at our list, 30 comes between 25 and 36. So we have the square root of 25, we have the square root of 36, and in between there is going to be the square root of 30. The square root of 25 is 5. The square root of 36 is 6. So we know the square root of 30 is going to be 5 point something. To get the denominator, we're going to find the difference between our two perfect squares. That is a difference of 11. Our numerator is the difference between the first perfect and the number we're estimating, and that's 5. So we have 5 and 5/11ths, and now we're going to divide. 11 goes into 5 0 times. 11 goes into 50 about 4. 11 goes into 60 about 5. Okay, so we're going to stop there because we're rounding to the 10th. So this 5 says let's bump this 4 to a 0.5. So about 5.5 is the square root of 30. Again, it's approximation. Number 4, the square root of 65. 65 is just barely, it is only 1 unit off from being a perfect square number. So it comes between 64 and 81. So we know this is going to be between 8 and 9 on the number line. So we're going to have 8 point something. To find the fraction, we're going to find the denominator first. So that's going to give us 6, 7, 17. And then from 64 to 65 is 1. So we have 8 and then 1 over 17. And we're going to divide 17 into 1. So 17 goes into 1 0, 17 goes into 10 0, and now 17 into 100. If that were 20, that would be about 5. So let's try 5 first. 5 times 7 is 35. And then 5 times 1 is 5, plus 3 is 8. And that gives us 15, so we're right underneath. So 8 and 1/17 is 8.05, which would round us to about 8.1, which makes sense because the square root of 64 is 8, a perfect square number. However, 65 is just outside of that perfect number, so 0.1, which makes sense. Okay, you need to try these on your own. So you're going to estimate the number, and then you're going to compare that estimation to the number given here. So you're just going to use either greater than, less than, or equal to. So you try these problems.